Okay, hello math fans. We've already learned about law of signs. Now we're going to learn something called the ambiguous case. Ambiguous case of law of signs. Okay, so before we get into the actual a problem here, let's just talk about why something is called the ambiguous case of law of signs. Alright, so let's make a quick sketch here just to talk a little bit about it. And I'm just going to draw a part of the triangle. So here is going to be angle A. This is going to be angle B, which I'm not going to sketch this aside quite yet. And angle C can be anywhere on this one side here. Okay, that's not marked. It can be angle C can be here, here. It doesn't really matter. Okay, so let's first start out with a problem here. If I give you an angle, and this is going to be fixed, so angle A, and I give you, and this is going to be side C. All right, if I give you angle A and side C, so let me kind of just mark this as fixed. So this angle's fixed, and this side is fixed. Okay, and then what you see in black is which is this other side here between A and C, which is actually side B. That's not fixed. So what I'm going to do first is let's actually come up with another side here that's going to be fixed. So if I said here's the length of side A, and my question to you is how many triangles, if I could move that side that I just drew, okay, how many ways can I draw a triangle? And what you're looking at right now is you're saying, well, you can't draw a triangle with that. It doesn't make sense to draw a triangle because no matter what, if I flip this around, you know, to here or to here, it doesn't matter. I can't draw a triangle. So in this case here, I have 0 triangles. Okay, I have 0 triangles. So that's one scenario. So let's look at another scenario here. If I have a length of a side that is about that long, okay, there's only one triangle I can draw because I can't take this triangle, I can't do anything else with the side. Again, the red is fixed. So I can't take the side and I can't move it over to here. There's only one place that connects is right here, otherwise it wouldn't form a triangle. So in that case there, I have one triangle. Okay, so let's get rid of that side. And let's make the side just that long. Well, how many triangles do I have for that? Well, I just have one triangle again because actually what's going on is what is forming a right angle here, and I can't move it. I can't move it here or here because it's only hitting it in one spot. So here's one triangle. Okay, now this is where, so it's an ambiguous case because again, I don't really know. I don't know how many triangles I have. So here's my last scenario. Okay, my last scenario is here's the length of my side. All right, and again, that's a fixed length. Well, okay, I have one triangle. Here's my, again, I can label this now. This is angle C over here, and this is my side B. I have a triangle, but I can also take that, instead of putting that point right here, how about if I take that and instead I put it over here? So I can flip that around to both sides. So I actually have 2 different types of triangles that I can form given one side. So in this case here, I have 2 triangles. So this is called the ambiguous case of law of signs because there's a potential to have no triangle, one triangle, or 2 triangles based on what's given. Now if you notice, again, what is in red? It's angle, side, side. Alright, so right now you're laughing because you see ASS on the screen, okay, but you need to understand that back in the day when you first learned angle, like for congruent triangles, you never could prove triangles are congruent by angle, side, side. Okay, and the reason now you can't prove triangles congruent by angle, side, side is just for that fact. I can have a triangle that looks like this, or that looks like this, and here's angle, side, side. So those triangles have the same angle, they have the same one side here and the same side over here, but these triangles are not congruent. That's why you could never use angle, side, side to prove congruent triangles, because they are not congruent. So that's what we're doing now, is we actually are going to use law of sines, and you're going to be able to determine whether or not you have one triangle, two triangles, or zero triangles. Okay, so the way you're going to recognize this now is, as I told you with regular law of sines, you are required to, when you're given the information, you're required to draw a picture and tell me whether it's angle, side, 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 angle, side, 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 etc. All right, so that's going to be your first step, and then you're going to recognize right away, oh, it's an ambiguous case of law of sines. So if I gave you, even before we start out a problem here, if I gave you a triangle like this, is that ambiguous case? Well, no, it's not. This is angle, side, angle. And if you remember from law of sines, the next thing you're going to do is you would find this angle here, the third angle. Okay, not an ambiguous case. Same thing if I gave you angle, angle, side. Not ambiguous case, because the deal is I can find the third angle and then I'm good to go. Okay, it's only when you are given angle, side, side. And don't get that confused with this. This is not the same thing. That is angle, or side, angle, side. Side, angle, side. That's a different case. That is, we use law of cosines for that case. So this one's angle, side, side. That's the only time you're going to use, think about the ambiguous cases, when you have angle, side, side. So when you see a bad word there, which is not really a bad word because it's really just a donkey, okay, then you will use ambiguous case law of sines. So let's talk a little bit about, let's actually do a problem with law of ambiguous case of law of sines. Okay, so the first problem here is, I'm just going to give you letters and then you're going to draw pictures. C is equal to 68.5 degrees. Little c is 258 centimeters. And little b is equal to 386 centimeters. So the first thing you're going to do, you don't even have to put the measurements on there. First thing you're going to do is you're going to label this triangle A, B, and C. And you're just going to mark off what's given. Hey, I'm given angle C, I'm given side C, remember it's opposite, and I'm given side B. Okay, so right away I have angle, side, side. I know this is the ambiguous case of law of sines. So we just move on from there. Not a big deal, we just need to move on and use the law of sines. Alright, so we have one ratio. Obviously we have that both C's are given. Okay, so we're going to use that. We're going to say 258 over sine of 68.5 is equal to 386, because we need to find, our next thing really we're trying to do is we're finding angle B. Okay, because that's the only thing we can find. We're given a ratio for C, side C and angle C, and we're given one side of B. We need to find angle B. So 386 over sine of B. So we cross multiply, and we get, so I'm just going to kind of show a little bit more work here now because this is important. So 258 sine of B is equal to 386 sine of 68.5. Divide both sides by 258. So sine of B is equal to 1.39. Now, if you put it in your calculator, you did inverse sine. Again, make sure your calculator's in degree mode. Inverse sine of 1.39, you're going to get an error in your calculator. Why are you going to get an error? Well, if you remember, what values is sine of an angle between? Remember, it's between -1 and +1. So if it's above 1, it can't be. So that has to be less than 1.00, right? It has to be less than 1. If it's greater than, so if it's greater than 1, then it's not a triangle. Then no triangle. And that's what you're going to put in the answer blank. So if you get, I don't care if you get an error, however you do it, but if you need to understand that if it gives you an error, don't put error on the answer blank, because error is not an answer. Okay, you should recognize, oh geez, it's greater than 1, or there's an error, so that's what goes in the answer blank. No triangle. Okay, that's actually the easy. That's really kind of the nicest one, right? You have no work to do now. You just kind of do one little step here and figure out it's no triangle. So that's this picture right here. Okay, so there's a little side right here. It doesn't matter how you move it around there, you're never going to get to the bottom side here. That's why it's not a triangle. Okay, so that's your first case, is no triangle. All right, so let's do the next case here. Angle C is 35 degrees 42 minutes. Little c is equal to 29.3 meters. And little b is equal to 38.2 meters. So the first thing you're going to do is you're going to draw a picture. It's required. If you don't draw a picture, you're going to lose a point. Even if you get the whole problem right, if you don't have a picture on your paper, you're going to lose 1 point. Okay, so we have angle C, we have side C, and we have side B. Aha! Angle, side, side. So we know, again, it's the ambiguous case of law of sines. So we're either going to have 0 triangles, 1 triangle, or 2 triangles. So let's just kind of start out here. We're going to have 29.3 over sine of 35 degrees 42 minutes is equal to 38.2 over sine of B. So if I do all my work here, again, I'm going to get sine of B is equal to 0.7608. Do not ever use a rounded answer. When you get that 0.7608, blah, 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 you're going to keep that in your calculator, and you're just going to hit inverse sine of, on your calculator, answer. Okay? And if you do that, you're going to get B is equal to 49 degrees 32 minutes. Okay, that's kind of nice. So we have our angle B. Now, of course, if I want to find angle A, that's just 180 degrees minus the given angle, 35 degrees 42 minutes, minus 49 degrees 32 minutes. So angle A is equal to 94 degrees 46 minutes. Okay, that's pretty nice. That's angle A. So there we got angle A, we have angle B, and the only thing we need to find is side A. So we're just going to use law of sines again to find sine A. So it's going to be 29.3 over sine of 35 degrees 42 minutes. And make sure, again, you're using the information that's given. Don't use our calculated value of B to figure out, in law of sines. Obviously, we have to use that angle A because we need to use an angle A. All right, so it's going to be is equal to side A over sine of 94 degrees 46 minutes. And some of you might remember from law of sines, one of the big things that I stress is that you cannot use law of sines to find the biggest angle. And you're like, well, wait a second, I have the biggest angle here. I can't use law of sines. We're not finding the biggest angle. We already know it. we can use the biggest angle, and the deal is that we can find the biggest side. That's not a problem. We just can't find the biggest angle with law of sines. Okay, so if I cross multiply and divide, I wind up getting A is equal to 50 centimeters. Okay, so there we go. We've got we have angle B, we have angle A, and we have side A. So those are our three answers. And think about it, when you're given a triangle, you're given three pieces of information, and you got to find the other three pieces of information. Now this is the deal. This is where ambiguous case of signs kind of comes into play. If you remember back in the day, which is just teaching about law of sines, I can have sine of theta is equal to 1/2. And remember, my answer can be 30 degrees, which is what the calculator would give you, but it also doesn't give you the other angle. And remember, 1/2 can be either here or here, and it's 180 minus 30 degrees, which is 150 degrees. So I really have two answers for this problem. And this is what we're going to do now. We are given this answer right here is for angle B. That's the one we first calculated using sine. That's very important. It's the first one we calculated. So what we're going to do is we're going to see if there's another value of B. If this is our first angle, to find our second angle B, and we're not sure if it's a possible angle. We have to check it. Our second angle B is going to be at 180 degrees. It's like this right here. Finding this 150, I did 180 minus 30. So we're going to do 180 minus 49 degrees 32 minutes. And that gives us 132 degrees, or 130 degrees, 28 minutes. Okay, that's the other possible value of B. Now this is the deal. This is really, really important step, is I need to know if that is a possible value. See this first value here? That's a given value of C. If I add, so this is angle C. If I add angle C to this, 35 degrees 42 minutes, and I add it, I get 166 degrees 10 minutes. Okay, if this value is less than 180 degrees, then I have two triangles. That's very important. Okay, if it's greater than 180 degrees, it's impossible. You can't have it. And that's actually going to be our third example, but this one is less than 180 degrees. So again, I took that value of B. That's the first thing I found is the angle B. I added that, or I subtracted that from 180 to find my other possible value of B, and then I added it to the given angle. I didn't add it to the angle A because I found angle A originally from subtracting everything from 180, and you don't want to use angle A. You want to use the angle that's given or that you found using sine. So basically the first angle that you find, that's what you're saying. It can either be that or 180 minus that. Okay. So it's there are two triangles. Well, I already found my angle B. Here's my angle B, right? I already did that. So what I need to do is I need to find angle A. Well, that's pretty easy too, isn't it? Just 180 minus angle B, our new angle B. So 130, 28 minus the given angle C. So minus 35, 42. And that's going to give us angle A is equal to 13 degrees, 50 minutes. Okay, so this is all for the second triangle. And then what I'm going to do is I'm just going to use law of sines to figure out my new angle A. So here I'm going to use 29.3 over sine of 35, 42, just like I did before. That's my nice ratio of C's. and it's side A over sine of 13 degrees 50 minutes. So if I cross multiply and I solve for A, I get A is equal to 12 centimeters. So I have three answers for each triangle. So for the first triangle, that's my first triangle answer, and first triangle answer. Okay. For the second triangle, here's angle B, and here's angle A, and here's side A. So that's it. Those are, I have 6 answers. Obviously, 2 sets of angle A's, 2 sets of angle B's, and 2 sets of side A's. And that is what the ambiguous case is. So I hope you understood that. If you didn't understand that, go back and watch the video again, because it's actually pretty easy. But the key here is you have to make sure that to find that second angle B, or second angle after you found, in this case here, that's the first angle is B. You do 180 minus that angle, and then you have to check it. So you take that 130 degrees 28 minutes, you add it to the given angle, angle C, and that's got to be less than 180. All right? Okay. Last problem here. If you are given angle B is equal to 54 degrees, 17 minutes, C is equal to 34.3 kilometers, and B is equal to 62.1 kilometers. Okay, first thing you're going to do is you're going to draw a triangle. Got to draw a triangle because we have to know, is this law, ambiguous case of law of sines, is it law of cosines, is it just law of sines? So we have A, B, C, and angle B is given, so mark that. Side C is over here, and side B is over here. Aha! Angle, side, side. Law of sines. We don't know what it is, what's going on here yet, but it definitely ambiguous case of law of sines. So let's kind of set things up a little bit. 62.1 over 50, or the sine of 54 degrees 17 minutes is equal to 34.3 over the sine of C. So before we even go any farther, this is the angle that you're going to check to see if there's a second angle. Okay, always check that first angle, because that's what it means. Ambiguous case of law of sines is it could be that, or it could be 180 minus that angle. Okay, so that's really important you recognize that. So anyway, I cross multiply and I figure out I get sine of C is equal to 0.4484. Of course, then I do inverse sine and I get C is equal to 26 degrees 39 minutes. Okay, and so let's figure out angle A is just 180 degrees minus the given angle, 54 degrees 17 minutes, minus 26 degrees 39 minutes. So angle A is equal to 99 degrees 4 minutes. Okay, that's good. And then, of course, I want to figure out side A. So we're going to use our 62.1 over sine of 54 degrees 17 minutes is equal to little a over sine of 99 degrees 4 minutes. And I cross multiply and divide, and I get little a is equal to 75.5 kilometers. Okay, so that's all that information for first triangle. So let's do our second triangle. Let's just check to see if we do have a second triangle. Okay, so remember I told you you're going to use angle C. So angle C was 26 degrees 39 minutes. So other possible angle C, that's just going to be 180 degrees minus 26 degrees 39 minutes. It's like a reference angle, and we're looking to see what it is. So we have our other possible C is 153 degrees 21 minutes. That's our other possible C. So now I'm going to add that to the given angle. So it's important. Add to the given angle, because the given angle is a fixed angle. Anything that's given is always fixed. So it's added to 54 degrees 17 minutes, which is angle B. If I do that, I get 207 degrees 38 minutes, which is obviously greater than 180 degrees. So it's not a possible angle. So really, in this case here, there's one triangle. Okay, so you don't have a second triangle, and so our answer is, here's angle C, here's angle A, and here is side A. There's only one answer on the blank. Now, a couple points here. First of all, you're going to be given a blank on a quiz. You're going to be given blanks, one blank for each letter that's missing. You're not going to be given two blanks saying, oh, there's two triangles or there's a possible second triangle. You have to know by drawing a picture whether it's angle side side, and then you're going to have on the blank, you're going to have to put in two answers. Okay, so it's going to say something like, angle B, and you're going to put in, oh, it's 50 degrees and 130 degrees. Okay, you're going to put both answers on there. If there's no solution, just write no triangle for the whole thing. You don't have to write on each blank, just write one time no triangle. And if there's only one solution, you're going to give me one solution. But do not forget to check for the second solution. That's the whole point of drawing this triangle, is that you know what type of problem it is. Okay, so you make sure that you draw a triangle and you determine what type of problem it is. And so that's what the ambiguous case of law of sines is. Okay, so if you have any questions about it, like I said, look back at the video, go back over that example, but it's very detailed in what I just taught you guys. And anyway, I hope you understand ambiguous case of law of sines. All right, math fans, have a good day. Goodbye.